Hello, I am Omni. I will be solving education at the first round, 151, and I will try to explain what I am doing. In problem A, we want to get number n as a sum of some integers. All of them should be from 1 to k, except we are not allowed to use number x. And we should print the answer. Okay. If k is 1, then the only number that we could use is 1, but it will be banned because x will be also 1. So the answer is just no. If k is 2, okay, if 1 is not banned, then we can just take n elements equal to 1. So now we're considering the case when x is equal to 1, so 1 is banned. We could try taking number 2, and it would work if n is even. And if n is not even, so n is odd, then we must take some odd number. But if k is 2, then it's not possible. We don't have any odd numbers available because the only odd number that is at most 2 is 1, but it is banned. So in that case, it would be impossible. And otherwise, we could use number 3 once, and then all the remaining numbers will be 2, and it is fine. So just a bit of casework. So if k is 1, then the answer is just no. Now, if n is even, then the answer is yes, and we can just, alright, no. If the banned number is not 1, then the answer is yes, and we will just take n numbers, all of them will be equal to 1. Now 1 is banned. If n is even, then we can take all the numbers equal to 2, and thus like the sum is n, so we should take n over 2 2's. Now if k is 2, so now 1 is banned and n is odd. If k is 2, then we cannot make any odd number. And otherwise, we can take 3 and a lot of 2's. The total amount of taken numbers will be n divided by 2 rounded down. then we will have a lot of 2's and one number 3. Problem B, we will be working with some infinite two-dimensional grid. We have 3 important cells because their coordinates is all that is given. We have 3 pairs, 3 people, all of them are in cell A in the beginning. So one person wants to go to cell B and the other wants to go to cell C. They want to go along the shortest path and they can only move like parallel to the axis. They want to go along the shortest path, but they want to walk together. What is the maximum possible number of cells that they can walk together? Well, when they walk by shortest path, it means that if current x coordinate is strictly bigger than the target x coordinate, then they can decrease that x coordinate in one move. If it is smaller, then they can increase but cannot decrease. If it is equal, then they cannot change x coordinate anymore. And the same is true for y coordinate, and that is necessary and sufficient to be the shortest path. So they start somewhere. We can shift everything so that the starting point is 0, 0, and then well, basically they want to make as much moves as possible while maintaining that they only do allowed moves for both of them. It's kind of not easy to explain, like it's just the this argument is kind of like geometrical. It's easy to see that it is independent by coordinates, and so x and y here are the shifts they should do in one coordinate. First we will talk about coordinate x and then coordinate y. If one of the shifts is 0, then we cannot move by that coordinate at all. And if they're of different signs, it means that they're moving in opposite directions in that coordinate. So again, they cannot move both by that coordinate, because that move would be banned for one of them. And if they are of the same sign, then they can move to the same in the same direction by this coordinate until one of them reaches the target coordinate. After that, they cannot move using that coordinate anymore. So we need to check that they are of the same sign, and if they are of the same sign, then we need to increase the answer by minimum of their absolute values. So if x is negative, I will multiply both of them by -1, so now x is non-negative. If x is 0 or y is 0 or negative, then they are of different signs, so we can't add anything to answer. Otherwise, they're both positive, and we are adding minimum of their, well, absolute values, but since both of them are positive now, that's just the value. I might have to add +1 depending on how they count the number of common cells. Like, yeah, they start at the same cell, so maybe it is counted as common. I guess it is. Problem C. When the problem name is strong password, that usually means that it sucks. The password consists of digits from 0 to 9. The length is exactly m. The password should not appear in the password database given as string s as a subsequence. Interesting. Came up with 2 strings. So for every position in the string, we have a range of available digits. And we need to answer if there is password. That's good. So the string, which is the database, is long, but our required password is short. Does it matter though? Like, we want to not be a subsequence of the given string, and the choice for each digit is independent of everything else. So shouldn't we just each time choose the digit that is like the farthest away in the string from the current position? Like, what is the algorithm to check if given string is a subsequence? It's just greedy. Like, we will scan string left to right in which we want to find the subsequence, and if we encounter a symbol that is equal to our first symbol, we're like, okay, that will be where we take the first symbol, then move further. Then we find like the closest position that is equal to the second, our digit, third, fourth, and so on. And like the algorithm succeeds if we found all the digits we wanted until we run out of the string. So if we want this algorithm to fail, we want for each digit to be as far as possible. So since the limitations are very small, it would be fine for every position, just iterate over all the available digits. For each option, just iterate from the current position, where we found the last digit, iterate through the string and find where the next occurrence of that digit is, and that's it. That would work in length of s multiplied by m multiplied by size of the alphabet. But we can do better. This limitation is not needed. We can pre-calculate for every position what is the next appearance of every digit. So that would take length of s times size of the alphabet size, and can be done in the same time complexity. We just go right to left, and what is the next occurrence for some particular digit from that position. Either it appears in the next position, then it is next position, or it is the same as if we started in the next position. So we can recalculate them in constant time. Now we pre-calculated the next occurrence for every position, and now we just run but doing the same, but instead of for every option just running through the string to find the next occurrence, it's just pre-calculated, so we just look at it in constant time. So that will work in length of s plus m multiplied to that sum multiplied by the size of the alphabet. So that would be fast enough, if m is big. Kind of a weird problem. It seems too easy. So now we're calculating the next occurrence, running right to left, and first we will copy all the answers from the next position, and then for the symbol that is next, we'll say that it occurs in the next position, and for all others the answer is the same as in the next position. Is it guaranteed that this is valid? Yeah, okay. There is at least one option every time. We want to find the one with the furthest possible appearance. And then we jump there. I almost always prefer to have like half intervals, including the left border, not including the right border, and that includes like situations like that. Basically, we calculate like if I'm standing before the is digit, where I will be standing after the jump. So like I was standing before the is digit here, so the next digit is one, and after that I will be like, in the next position, and if like this digit does not appear in the string at all, it's n+1. Like there is no such position. So I jump here. But I should stop at some point, like maybe I have run out of the string, and then like when that happened, like if I set some digit and then it is not found, so I should just print yes and be done. Well, that happens if well, we jumped over the, to n+1. Just print yes, and otherwise print no. Problem D. I am developing a rating system for an online game, apparently. Initially, the rating is 0, there are n matches, so we're just given the rating change. There are no zeros. Okay, the system has an additional rule. For a fixed integer k, if a player's rating has reached the value k, it will never fall below it. Okay. Your task is to determine the value k. Okay, so it's not given. In such a way that the player's rating after all n matches is the maximum possible. Okay, so the sequence of changes is given to us. Let's look at the rating graph. It will, like, if we do not apply any k, it will be something like this. What if we apply some value of k? So after the first time the rating becomes greater than k, then here we will actually only decrease to k. So we take like this part, the suffix of the rating graph, and move it higher so that this point gets on the line. But then we have another decrease, so actually we have to move this point so it gets to the line. Then we have an increase. It will process as usual. So like after this increase, we will have something like this. After this increase, there is another decrease, and it goes lower than k again, and so we should stop here actually. But then the increase will be processed as normal. So in the end, what actually happens is that we find this lowest point, and basically we ignore everything from this point to the lowest point and move the lowest point to this line k. But we should have crossed that line before. Again, I'm not sure how to like strictly formulate it, but that's what will happen. Because like every time we reach some part, all that was on the suffix, it is shifted together by the same value. So like in the end, all the values should be at least k, and if something was lower than k, then it will be moved up, but it will be moved up with everything that is on the suffix. So like the minimum point will be moved to the line k. So actually the best we can do, what we gain from it is this distance. Like without all the moves, the final rating was like this. But if we move this minimum point to this level, then the final rating will also move by the same delta. So we want to maximize this distance. What is this distance? Like how can we choose this line? Can we just put it in the infinity? No, we must cross it before that minimum point. So we want to choose this line such that like if we fix this minimum point, we want to choose a line so that before the minimum point there was rating that reached it, but we want to maximize it under that conditions. So actually we want to find a pair of points such that like we want to maximize the left value minus the right value, and basically like in terms of given deltas, it means that we want to find a segment with minimum sum, like the largest negative sum, the largest by absolute value negative sum, and that will be what we want. And the corresponding value of k, like we actually want to draw this line like this. So we want to find actual value k. At least one of the optimal answers, so we can print any k that is optimal. So we want to find the segment with minimum sum, and the answer is prefix sum in the left border of that segment. don't even need to store the numbers. So I will have answer, current maximum balance, and current balance. So if right, I also need like maximum delta value. If maximum balance minus current balance, which is the value we will get if we choose this point as the right point, is greater than max delta, then I should update the answer. Update maximum delta and update the answer, and the answer is updated as max balance. Problem E. Yay, combinatorics. I hope. There are n boxes. Some boxes contain one ball and the rest are empty. At least one box contains a ball and at least one box is empty. In one move you have to choose a box with a ball inside and an adjacent empty box and move. Okay. Boxes 1 and n are not adjacent. They're in a line, not in a circle. How many different arrangements exists after exactly k moves? So like we have a string of zeros and ones, and we have to exactly k times swap neighboring 0 and 1, right? Because at every moment each box contains no more than one ball, because we cannot add balls to the box that is not empty, and therefore when we take the ball out of the box it becomes empty. So we always like swap 0 and 1. Like we take 1, take its neighboring 0, and decrease 1, increase 0, but that's just a swap. Alright. So each move changes the number of inversions by 1. And like every move can be undone. So like it says that we do exactly k moves, but like if we want we can do less than that but with the same parity. So the parity is important. Let's say that okay, the number of balls will also not change, obviously. So let's say we fix the configuration we want to get in the end. So let's say that we start with configuration like this, and we want to get to a configuration like this. Since we always swap only neighboring 0 and 1, it means that the relative order of ones will not change. And so we know that this one should move here, this one should move here, and this one should move here. So we need to pay at least the sum of distances. But I say that the sum of distances is actually like the minimum number of moves here. Like what do I want to check with this final configuration is that what can we achieve it in exactly k moves. But then I say that if we can achieve in k moves, then we can also achieve in k plus 2 moves. It is guaranteed that we have 0 and 1 somewhere, so it's always possible to find a pair to swap and swap it twice. That will not change the configuration. So I want to achieve my configuration in the minimum number of moves with correct parity, but actually I cannot choose the parity because, for example, the parity of the sum of the positions of ones is it changes every move, or like the parity of number of inversions, like some valid parity changes after each move. So for a final configuration, I know the parity of the number of moves I need. So what do I need to check is the minimum number of moves. Right. And why do I say that it is always possible to do in the number of moves that is equal to the sum of distances? Well, I need to show that like it's there is always a valid move, and that is done something like this. Like, let's find the leftmost one that is not on the correct place. So we can start with something that is already correct, and then like there is one that is not in the correct place. What are the cases when either it want to move to the left, then we know that there are zeros up to this one, and this is the correct position of this one, so this is on the right, so we can always move to the left if we want. But it can also happen that we actually want to move to the right by a lot, and there can be other ones here that can they must moved even further here. But then I say, okay, like let's then take like for example the rightmost of the ones that stops us, or like actually any of them. So let's take this one. It stops this one from moving to the right, but it is on the right, like in the current string, so its target position should be even more on the right. So like from here we wanted to move here, and this one is somewhere on this segment, but it actually wants to move even further. So it also wants to move to the right. Can we move it to the right now? No, there is like other one bothering it, or maybe there is more like here. But anyway, we can change which one we want to move, change, and all the time we will be only moving to the right, and everyone we change to, it also wants to move to the right. So our string is not infinite, so at some point we have to stop, and we can only stop because like we can right now move this one as we want, and that's That's it. Like, so we can make a move that is good, like that. We spend one move, but we also decrease the sum of distances by one. So in the end, we will spend the number of moves that was equal to the current sum of the distances. Alright. Now we have to add some kind of dynamic programming to it. Time limit is 5 seconds and limitations are 1,500, which is weird. It almost seems like they don't want to allow cubic time solutions, but I would be very surprised if cubic time solutions do not pass. Okay, so what do we want? Let's try to come up with some DP and see what will happen. So we need to calculate the number of configurations that we can get. So we will build configuration. We'll go left to right. We know the number of ones we should place. And for every one in the initial string, we know its position. So let's say that everything is constructed. So what do we want to store in the state? The length of the prefix, the number of ones that we already placed, and I guess like the sum of distances for the ones that we already placed. What are the transitions? Well, we can either put 0 or 1 in the resulting string. If we put 0, this and this doesn't change. If we put 1, then this is +1. And for this, like, we calculate the distance from the current position to the position of the corresponding one in the initial string. We know which one is corresponding because we know the number of ones here. So like we add the distance. Okay, that's and if the sum of distances became greater than k, then it's bad. So this is bounded by k, and it's n square k. Actually, it should be smaller. I mean, like the complexity is like this, but probably like divide by something, because not all the number of ones are possible. Like for example, if we have more ones than zeros in the initial string, we can just flip all the bits, and now we have less ones than zeros, and so this is actually bounded by n/2. I cannot believe that this doesn't pass. It must. Is something better? The limitations look like they wanted something better than this. On the other hand, like I can't see what to optimize. Like we have cubic number of states, and as far as I can see, all of that information is needed. Okay, well, let's just write that. I can't see what can we optimize here. So, um, there is always a transition that does nothing. So, like in any case, we need to optimize memory. So I would like store only 2 layers by like, size of prefix, but actually I can just not store prefix at all. I'll just iterate over it, and like there are transitions that at 0 that does not change these two parameters. And so like I will not do them, basically just storing the same thing, but I need to be careful like, in which order to do the transitions. If I have too much ones and half, then I should flip everything. What I actually need from input is the positions of ones. Iterating over the position, iterating over what was the number of ones before I place this one. If I want to place it here on position I, then the increasing distance will be the distance between I and the position of J's one in the initial string. In the end, I must place all the m1s and the number of operations should be at most k and have the same parity as k. And I don't have any multiplications, only additions. The additions are done in unsigned int, so it should be super fast. You probably could have tested on something for running time, but testing system will do that for us. Not even 2 seconds. And the last problem, problem F. This looks bad. There is a pool of length L where n swimmers plan to swim, start swimming at the same time. They take different lanes. Okay. Each person swims along the following route. Start at point 0, swim to point L with constant speed, which is given. Yes. After reaching the point L, the swimmer instantly turns back. So nothing unusual. Let's say that some real moment of time is a meeting moment if there are at least 2 swimmers that are in the same point of the pool at that moment of time. The pool will be open for t seconds. You have to calculate the number of meeting moments while the pool is open. All the speeds are different, including moment t and excluding moment u. And we need to calculate the number of moments of time, not the number of pairs of swimmers that will meet, but if in the same moment of time there are many meetings, maybe a lot of swimmers will meet at the same point, or maybe like there are 2, 3, 4 meetings at different points, we still have to calculate this moment once. Okay. So let's say we have swimmers with speeds v and u. At what moments of time will they meet? Let's say that v is greater than u. Then first they will meet like after the faster one reaches this border, and then some, and the slower just finishing their first lap. Well, not lap, first swim. So that happens at moment of time 2 times L divided by v plus u, because it's, well, the total distance they need to traverse is 2 times L, and the sum of their speeds is v plus u. What is the limitations? Oh, okay, so L and time are big, but v's are kind of small. Looks like a 50 problem. We probably will need to look at those sums, but okay, let's think more. What is the next meeting moment? Will it be like for L? If they meet at some point, they're going in different directions here. And they will meet after they traverse again like full lap, which is 2 times L. Will it always be like that? Well, it shouldn't be always like that. For example, if v is much more than u, then before the slower one finishes his first swing, the faster one will go like there and back and there, and will start and I mean like they will meet again at some point x, such that 2L plus x divided by v is equal to x divided by u. It feels like it is like correct in general. Like if they meet like face to face, it means that in total they swam like some number of full laps, so it's like times like 2L multiplied by k divided by v plus u, where k is integer, and well, we only consider consider times that are greater than 0, so positive integers. But also they can meet if one overcomes the other, and that would happen well, we can try to solve this, and what we will see, I guess, is that this x is not important. Like the time should be, I think, 12 divided by v minus u, but let's see. And then we substitute x here, and yeah, we get this. Well, yeah, it makes sense. Like, if they meet, like when the faster overcomes the slower, it means that the faster one swam some integer number of laps more than the slower one, and the speed with which, like, the difference between the distances they cover increases is this one, and so it must be like some integer amount of full laps divided by the speed. Alright. So yeah, we can using fast Fourier transform, we can get all the numbers of this and this form. And then we should just answer how many moments of time before the given border can be written in this form. 2 times L times something integer divided by one of the given numbers. We will just find all of them. It's probably some kind of inclusion-exclusion. Like, we have those sets of times that are good, like that. So let's say that we have this collection of numbers, and we want to calculate the number of numbers that can be written as 2 times L times K, where K is something strictly positive divided by xi, and it should be at most big T. For given I, it is easy to calculate how many numbers like that exist. Let's just solve for k. Right? K should be at most T times xi divided by 2L, and we only consider integer numbers k. So the number will be just this rounded down. But we will calculate something many times, like the same moments of time many times, because because we can the same moment of time can be of this form for many different i's. But basically we can consider like sets of those moments of times that are like for every I, and we are interested in the size of the union of those sets, and that's exactly like what inclusion-exclusion principle is used to solve. So what we want to be able to do is like we want to consider all the subsets of those indices and calculate the numbers that are representable by all of them at the same time. But that's kind of easy. Like they should be representable as like it's a time where basically the GCD of all those xi's should be here. Actually, we can write this as like k divided by xi at most divided by 2l, and then we can see that those are just numbers with like rational numbers with given denominator, and if we want the number to be representable with like some given sets of denominators, then it should be just representable as number with denominator equal to GCD of them. Right. So for each number we want to be able to calculate like for what sets of given numbers it is a GCD of them. That sounds like another inclusion-exclusion. Oh, look, we don't want to have we want to sum like -1 to the power of size of that set, actually, something like that. And so it seems that like for all the divisors we want to for fixed number g, if we want it to be not GCD but just divisible by g, then for every xi that is divisible by g, we just multiply the answer by -1, basically. Or wait, no. Something is wrong here. We can either take it or not take it, and when we take it, it's multiplied by -1, so it's multiplied by 1 minus 1, which is 0. That's interesting. So for all the numbers that are divisible by something, it is 0. But actually it should be like 1 minus what we calculate. So it will be 1 for all the numbers that divide something of what we have, but then we need to like apply another inclusion-exclusion to make it like GCD actually and not just divisible. So like after that, from each number, like from largest to smallest, we will subtract all the coefficients that we actually have, like for all the numbers that are divisible by this one, and those are the coefficients that we should use in the end. That should work. I mean, okay, let's write that. Okay, so to find all possible sums, we need to consider the polynomial of this with coefficients 0 and 1 where we have that x, and take a square of that polynomial. And then all the non-zero coefficients will be of the powers that are representable as a sum of two numbers. But it can be only representable by the sum of the number with itself, so we need to be careful about that. So if the current number we are checking is even and we had the number I over 2, then I should subtract 1, and if x is not 0, then we can have this sum. Now the same, but with basically we want like for differences, we want to have a polynomial where all the powers multiplied by -1, but it is not polynomial because we have x in negative power. So instead of like multiplying by -1, we multiply by -1 and then shift it, which is basically just reverse in place. So that's what I did here. Vector b is just vector a reversed. But because of shift, like when I want to consider some number I need to remember that I need to actually look at the coefficient of big N plus I in this polynomial, because like all the powers of b were multiplied by x to the power of n, basically. That's what we did when we shifted. Now we don't have an issue with number being in sum with itself, because number with difference with itself is just 0, and we do not consider 0 anyways. We consider only positive numbers here. Okay, so now in array A we marked all the numbers that we do have. Okay, so now in array B I want to set 1 for all the numbers that divide something that we have. And now first application of inclusion-exclusion, but kind of like in a stupid way. Just saying that we summed up all the coefficients, -1 in the power of size of the set, +1 actually, over all non-empty sets, in which all the elements are divisible by number I, but we want it only to be the sum over the sets where GCD is I. So to remove others that have GCD that divisible by I but bigger, we'll just go over all the numbers that are divisible by I but bigger and subtract what the coefficient for them were. Right, and I should like probably do this. I'm pretty sure that I can do it in link-longs and nothing bad will happen, like no overflows or anything like that. But just to be safe, I can use this mint we need to do it modulo 10 to the 9 plus 7. Like I needed FFT, but I could have done it in like complex numbers, or I used FFT in like modulo 9 and 8 and so on, because I didn't care. I only needed to consider like what numbers can be represented as sum or difference of two numbers that are given. And so like I'm multiplying polynomials of zeros and ones, so all the coefficients in the result will be like up to 200,000, and I only need to check if they're zero or not. So I could have done it in complex numbers, I could have done it in like modulo. I have FT pre-written with modulo operations. So now I want to use modular arithmetic, but actually when I will be calculating the answer, and up to this point I never used it like this. I mean, didn't use different models in the same problem, but it should work, right? C++ is too hard for me. Okay, so coming back, I set 1 for every number that divides something that we have. And now for every number I will iterate over all bigger numbers that are divisible by it and just subtract their coefficient. Alright, so now we do have all the correct coefficients, and so now I need to add the number of correct values of k, so like this, where xi is just I. But with the coefficients that I calculated. One, two, three, 4. That's not correct. I shouldn't have 4. I also shouldn't have 2. So like something is wrong here, probably. Should be equal to 0. Okay, but then it that's quadratic, yeah. Also incorrect. Slow and incorrect, the best kind of solution. That's a cool problem. The statement is very natural, and I mean, the A50 part is kind of bogus, like it's not related to anything else in the solution, but I mean, with natural statement, why not? It just happens that we had to find all the numbers that are representable as sum or difference. I guess you can like use bit sets, and it should be fast enough. 3 seconds. So for that part, it might be good with bit sets, and should be okay without 50. But then the other part is very nice, like nested inclusion exclusion. Maybe it can be done simpler. Like this is pretty stupid. But I don't know. Kind of cool. I like it. All other problems, kind of. Yeah. Well, for E, I'm interested if the intended solution is faster. That would be cool, but how? Maybe some kind of like square root. Yeah, I don't know. Like maybe because of like the sum of distances is bounded by k. We cannot be too far or something like that. Yeah, that's actually probably true. Like the other way how we can write this, like no, let's see. I had something like this, and the resulting one is the same number of ones, right? So the sum of distances is like 1 plus 2 plus 2 plus 2 plus 1. But like how I drew it here, we can consider those breaks between positions, and like the number of intersections is basically the number of times we have this unit segment. And so instead of calculating the sum of distance, we can calculate the number of intersections. And the number of intersections is basically when would we have an intersection? When the left border is before the right border. But left borders, one kind of borders are initial positions of ones, and the other kind of borders are final positions of ones. And basically the number of intersections in the given position is like the absolute value of difference of prefix sums, in a sense. And if and well, the prefix sum is basically our parameters, number of ones we set. The number of ones up to this point is like the sum of the 0, 1 array to this point. And if the difference becomes too big, like let's say it is d at some point, then at the next point it will be at least d minus 1, because like it both prefix sums can only change by 1. So if the difference was d, then it cannot be smaller than d minus 1 in the next position, then d minus 2, d minus 3, so on. But the sum of those values is our like minimum number of iterations, so it is bounded by k. And that means that if d is too big, then the sum will be at least like, well, basically d squared over 2. So d, if d is bigger than, basically if this thing is bigger than k, which is a bound for a number of operations we can use, which just means that, well, d is bigger than square root of 2k, roughly, then there will be no valid solutions. So this difference, absolute value of difference of prefix sum is always bounded by this thing. And so when we had dp prefix number of ones and this number of operations, which like we consider it as sum of distances, but we can also consider as like the sum of difference of prefix sums. Right, so the number of ones, if we store, well, it doesn't matter how we store it, but the number of ones cannot be very different from the number of ones that was at this position initially. So the number of ones minus like the initial prefix sum at this position is bounded by square root of 2k. So the actual number of states is n 2 square root of 2k and k, and so like the complexity would be n times k to the power of 1.5, but there is like this constant which is not super nice. And like very small k are probably like not viable, but still, like, the limitations should have been bigger. This is a nice optimize, and like it actually is faster, but not by a lot. Like, so in my DP's number of states was like this, and here it would be like this. So the difference is like here we would have this number, and here so this is 5.5, so it's roughly 110. I mean, 7 times faster. I'm sure it can be cut. That would be a better problem. I mean, 5 seconds. Like, what they expected? How can it be slow? Yeah. Thanks for watching. Bye.